Optimization, the largest or the smallest value that a function for some constraints, which must be true regardless of the solution. Finds the most suitable value for a function within the given domain. Variables are labeled x1, x2, x3, and so on, which are the inputs, things that you can control. They're usually abbreviated x to the n to refer to individuals. Constraints. They are equations that place limits on how big or small some variables can get. One, find the equation, say f of x, in terms of one variable, say x. Two, find the first derivative of the function. Three, set the derivative f prime of x equal to 0 and solve. Four, use the second derivative to figure out whether the point is a minimum or a maximum. If the point is less than 0, then it is a maximum. If the point is greater than 0, then it is a minimum.
Example 1 reads, a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that are the largest area? So let's start off by drawing a picture so we can really visualize the problem. So here we have the river, and here we have the fence that the farmer wants. With the fence being rectangular, this is our length, and these two are our widths. Now let's start with the constraint problem. So our constraint is that P, being the 2,400 feet, equals 2W, since we have two widths, plus length. Let's substitute the 2,400 for P. So 2,400 equals 2W plus L. We want to get a variable on our own, and since L is the only one, the L is going to be alone. So what we're going to do is move the 2W to this side. So L equals 2,400 minus 2W. Now let's write the beginning for our maximum area. So our maximum area is going to be area equals length times width. And for this, we can substitute our L to go in here. So area equals 2,400 minus 2W times W. Next, we're just gonna multiply in. So area equals 2,400 W minus 2W squared. Next, we're gonna solve for 0 when doing with our first derivative. So first, we need to find the derivative. The derivative of 2,400 W is just going to be 2,400. And then subtract the derivative of 2W squared is just going to give us 4W. And we're going to set that equal to 0 and solve. When setting this equal to 0, we are going to first move the 2,400 onto our other side by subtraction. So it's going to be negative 4W equals negative 2,400. Now, because we need to get W on our own, we're going to divide by negative 4, which we're going to get W equals 600. Okay, 600 turns out to be our maximum value. We can also check it on our number line. So on our number line, if we take a look, with 600 being here, the numbers before that on our graph are increasing, and after that they are decreasing, which means that because it changes from a positive to a negative at 600, and 600 is the only point in the domain, the absolute area must happen at this point. To find our absolute area, because it's asking for our largest area right here, we're going to plug in 600 into our first derivative. So we're going to have 2,400 minus 2 times 600. And that is going to equal our area, which is going to be 2,400 minus 1,200 equaling our area, which thus our area equals 1,200 feet. And this is our final answer.
A manufacturer wants to design an open box having a square base and a surface area of 108 inches squared. What dimensions will produce a box with maximum volume? Alright, I'm going to start by drawing a box. So we know that the surface area is equal to 108 inches squared. And a formula that we can use to find surface area is x squared plus 4xh. A formula for volume is x squared times h. We can start by plugging 108 into our surface area formula. So x squared plus 4xh. So to get h by itself, start by subtracting x squared on both sides. From there, divide both sides by 4x. and that will get you h is equal to 108 minus x squared over 4x. Plug that into our volume formula, x squared times h. So it would be x squared times 108 minus x squared over 4x. I'm going to simplify this. So x squared 100 over 8, and then minus an x squared over 4x. Multiply the numerators by x squared to get 108 x squared over 4x minus x to the power of 4 over 4x. That would simplify to 108 over 4x minus a fourth x cubed. This simplifies more to 27x minus a fourth x cubed. So we're going to find the first derivative of this. 27 minus 3 over 4x squared, and then set this equal to 0, and you'd get 27 is equal to 3 over 4x squared. To get x by itself, you have to multiply each side by the reciprocal of 3 over 4, which is 4 over 3. So you would get x squared equals 27 times 4 over 3. 27 times 4 is 108 over 3 is equal to 36, which is equal to x squared. And then we just take the square root of both sides to get x is equal to 6. And we're going to take this 6 and we're going to plug it into the surface area equation or formula. Alright, so 108 is equal to 36 plus 24h. Alright, subtract both sides by 36 is equal to 24h. Divide both sides by 24. And get h is equal to 3. X is 6 and our height is 3, and so our dimensions would be 6 inches by 6 inches by 3 inches. And these are your dimensions that will give you the maximum value.
Example 3. We have a piece of cardboard that is 30 centimeters by 20 centimeters, and we are going to cut out the corners and fold up the sides to form a box. Determine the height of the box that will give a maximum value. First, we'll draw a diagram. Now, we have to find the corners of the cardboard and take it out. And if we want to take out the corners, we have C as the corner. And for each of the side, we want to take out the two corners. So we have 20 centimeters minus 2C and 30 centimeters minus 2C. Now we have the cardboard labeled, and now we will shape it into the form of a box. Now we will find the volume of this box. V equals C for the height times 30 minus 20 to C times 20 minus 2C. Distribute the numbers. Now if we simplify the equation, it will be V equals 4C cubed minus 100C squared plus 600C. Now we will find the first derivative to find the critical point. V to the first derivative will equals 3 times 4, 12C squared minus 2 times 100 is 200C plus 600. The opposite of B will be positive 200 plus or minus square root. Next, B squared will equal negative 200 squared, which is 40,000 minus 4 times A is 12 and multiplied by C is 600 over 2 times A is 12. And that will equal to 200 plus or minus the square root of 11,200 over 24. If we do it on the calculator, the critical points will equal 12.74 and 3.92. Now we have the critical points. We will find which one will be the C, or the height. Will be C being greater than 0 and less than 10. How do we get 10? Is that 10 is the half the amount of the smaller side of the box, which is 20. So C won't equal 12.74 and will equal 3.92 as the height. Now we will find the second derivative of the first derivative. We will be finding the second derivative because we have multiple critical points. So 2 times 12 equals 24c minus 200. And if we plug in the first critical point, 24 times 12.74 minus 200 equals 105.76. And when we plug in second critical point, it's 24 times 3.92 minus 200 will equal negative 105.76. And because this one have a negative answer, that means, or the height that will give the maximum volume is 3.92 centimeters.